Hello, welcome to math today. Today we are doing pages 17 through, I think, 19. Yeah, 17 through 19. Okay, so this is about the shifted form of the parabola, which is really the same as vertex form. So when you have vertex form, the nice thing about it is you can see what transformations have been done. So think back. Transformations. We have reflections, rotations, translations, and dilations. Okay, so we're going to be looking at the A. We're also going to be looking at the H and the K. Okay, so if A is less than 0, the coefficient is negative. So what happens if the quadratic term is negative? Well, if the quadratic term is negative, you get this, which is a reflection over the x-axis. It will not change the vertex. It will not change the width or anything. It's just a reflection over the x-axis. Now, if the parabola is not on the x-axis, it'll just reflect it over the line that contains the vertex. So if it was like 3 units up, it would reflect over that line. Okay? So that's a reflection. Sometimes we say that it now opens down. Okay. What happens if A is greater than 1? Well, we're comparing it to when A is 1. So when A is 1, it has a certain width to it. If A is greater than 1, it gets narrower. Narrower. That's called a vertical stretch. It gets narrower. Okay, so as compared to a 1, a 2 would be narrower or closer towards the y-axis. Okay, if A is between 0 and 1, well, we know that A can't be 0 because if A is 0, then it's not a quadratic and we wouldn't even be talking about this. Okay, so if A is between 0 and 1, like a half, a third, 3/4, okay, that is going to be a vertical stretch. I'm sorry, shrink, vertical shrink, misspoke. Okay, which means that it is going to go closer to the x, so it gets wider. Okay, vertical shrink. It gets closer to the x-axis, further away from the y-axis, wider. Okay. So now if k is positive, so remember that it's y equals a parentheses x minus h squared plus k. So we're talking about the k, the number that comes after the parentheses. Okay? So if k is positive, it's a shift up or a translation. If k is negative, it's a shift down or translation. So it's equal to the same number of units. So if k is plus 3, it goes up 3. If k is minus 3, it goes down 3. But it has to be in vertex form. That's not the same as the c when it's in standard form. When it's in standard form, the c, the constant term, is the y-intercept. Okay. So now we're going in the parentheses. So when h is positive, it looks like it's negative to you because remember that it's x minus h squared. So like you look at it and you're like, oh, that's a negative number. But it's really not. It's really a positive number because when you subtract a positive number, it looks like minus that number. So really, in this case, the h is positive. So that's going to be a shift to the right. And again, remember that this would be when h is negative, it really looks like this, and that's going to be a shift left. Okay, I had said like it's kind of counterintuitive, but the reason that it looks different than what you first see is because you have to remember that the formula is subtracting it. When you subtract a negative, that's the same as adding. Okay? You can also find this in your textbook. If you have your textbook at home, it's on page 288 in the textbook. All right, so let's go on to page 19. Oh, how are H and K related to the vertex? H, comma, K is the vertex. How does A affect the average rate of change? So it will dilate, it will increase or decrease. So remember that the average rate of change is found by like finding 2 points and calculating the slope. So normally, let's say if I had A equal to 1, like if this was my vertex, from here to the next integer point and from here to the next integer point always has an average rate of change of 1. But if A is 2, from the vertex to the next integer point will have an average rate of change of 2. It's steeper. Okay. The graph to the right oh, hold on. I think you're supposed to do page 19 by yourself. Oh, no, I'm doing it with you. Okay. All right. So the graph to the right contains the following functions. Match their letters to their correct curves. Okay. So anything upside down would be B or D. B has to be narrower because 2 is greater than 1.
It's not an hour. He's been back in there for 5 minutes.
Okay. So now I did B and D. So now I'm comparing the 1/4, which would be the widest. And then I'm comparing the 1, which would be the next. And then I'm comparing the E, which is the 3, which makes it the narrower. Narrowest. Narrower. Okay. All right. So now I'm looking here at the vertex. So the vertex is 1, comma, 1, 2, 3, 4, 5, -5. So 1, comma, -5. So this would be incorrect and this would be incorrect. So now I'm looking at the distance here to the next integer point. So from here to here, the next integer point, if I calculated that, that would have a slope of 2. So it's going to be choice 4. Okay. Using the method of completing the square. Okay, now these are optional. I'm just going to show you one of them to remind you, but you really only have to be able to do this when the coefficient of A is 1. Okay, so y equals 3 parentheses x squared minus 4x plus 17. So basically you want to pull the A away out of the quadratic term and the linear term. Okay, now I move the 17. So that gives me 3x squared minus 4x plus, I don't know. So now I want this in the parentheses to be a perfect square trinomial. So you take half of -4, which is -2, and square it, which is 4. That's a 4, but it's really 3 times 4, which makes it 12. So I'm going to add 12 on this side. So I get y minus 5 equals 3 parentheses x minus 2 squared. And then I just move the 5 back. So that gives me y equals 3 parentheses x minus 2 squared plus 5. So use the method for completing the square to write each of the following quadratic functions in this form. I did that. Identify the turning point. So the turning point would be 2, 5. Since the 3 is positive, the parabola is going to open up like that, which means that this is a minimum point. Okay, I will post the key for this. So if you want to do B and C, that would be super cool. You can send it back to me and I'll check it for you, but you can always look at the key. All right, have a great day. I'm going to go take care of that baby you heard crying.